So hello everyone, good afternoon and good evening to the nationwide listener. And my name is Yang Ye in Chinese, but in English you can call me Ye. So today, thanks for the conference inviting me to give a speech about this vehicle-to-grid and blockchain application. I'm from the state-grid electric vehicle service company. So today, I hope I'm gonna illustrate this topic from the industrial point of view. Not a lot of scientific work here, but I just want every listeners to know our concern from the practice point of view. Today I'm gonna talk about from these three aspects. The first one is the carbon neutral target and development of EV and charging facilities. And the second one is the vehicle-to-grid technology and some innovative projects. And the last one is the blockchain-based energy tracing method for the EV charging. So from the last section, I heard a lot of experts has already mentioned how important we need to reduce our carbon emissions. So here is a little history about China's carbon neutral targets. So I think the first proposed one happened in 2015 on the United Nations Climate Summit, which nailed down Paris Agreement. And in the last year, 2020, on the 5th anniversary of the Paris Agreement, China proposed we need to reach to the peak in 2030 and achieve to the carbon neutral in 2060. So that's a huge goal for China, and also it's if we can do it, definitely we need to do it. If we achieve that goal, that's gonna help the worldwide a lot. So this is how China carbon neutral pathway. If we want to reduce our carbon emission, we need to know where it come from. So if we look at the International Energy Agency data in China, we can know that half of them are coming from the electricity and heat generation, and 30% are from the industry and 10% from the transportation area. So you can see if we are targeting these four actually areas, we can reduce our carbon emission tremendously. And if we analyze which area we need to be focused in, we can see from the electricity point of view, we can use renewable energy and the CCUS and the hydrogen to reduce our carbon emission. And from the transportation area, we can use public transportation, electric vehicles, hydrogen, and biofuels. These methods to reduce that. These electricity and transportation areas are comparatively easier than the heat and industry. So I think in the near future, our nation will targeting in these two areas to reduce their carbon emissions and to get the carbon neutral target done. After we reduce our electricity carbon emissions, the industry and the heat areas will be benefit from that. So this is a carbon reduction plan and EV development. So from this slides, you will know how the EV development are connected with our carbon reduction plan. So if we want to reach to the peak in 2030, we need to, from the power generation side, we need to lower our carbon emission by using the renewable energy, replacing the fossil fuels. And in this table, you can see our target is the renewable energy going to take up to 80% in 2060. So this high penetration level of renewable energy in power system really requires multi-time span energy storage technology and electrification of other areas. Then we can use them as a balanced resource to absorb the fluctuation from the renewable energy generation. And from the other side, we need to have a low carbon transportation by using the EV replacing the fuel car. So from this picture, you can see in 2020, there are almost 5 million EVs in China. I think this is most biggest market in the world. And by 2025, China's EV ownership will reach to 50 to 80 million vehicles. So with an average of 60 kilowatts hour battery, 80 million EV would have an equivalent capacity of 4.8 billion kilowatt hour batteries. So from the grid side, from the generation side, we need multi-time span energy storage. And we can, our company is a great company. Our company cannot afford that money to put on in this all kinds of battery storage installation. But from the EV transportation side, we will have a lot distributed mobile energy storage resource. So reasonably, we can think about if we connect the vehicle with the grid, which is V2G, it can be the bridge connecting the electrification of transportation and the clean power supply. So this is our company, State Grid Electric Vehicle Service Company. So our goal is to serve the national EV market and serve the national energy transformation, to build an energy internet enterprise and promote the electrification of transportation and support the clean energy generation. So by having these goals, actually right now, we build a smart vehicle networking platform. This platform is monitoring and controlling more than 1.2 million charging facilities in China. And we build 10 vertical and 10 horizontal highway backbone network. And also in the rural area, we have charging network. So that's why we have so many charging facilities, because our people have more than 5 million vehicles with their requiring the charging their cars every day in their daily life. So if we look into this 1.2 million charging facilities, we can have these 4 major categories. The first one is residential. So in the residential area, every user will have AC, which I believe is called a level 1 charger in Europe. And right now in China, we call it just a slow charging station, which is only like 7 kilowatts. But in the public areas, they will have 60, 90, 120 kilowatts AC, DC charger, and they will also have the bi-directional DC charger, which is right now, I think the most popular one is 15 kilowatts, and they will have 20 kilowatts and 60 kilowatts version in this year. So in the highway and the public charging, they will have 60 and 120 kilowatts options. In the rural area, due to their grid conditions, they will, normally they have like 20 kilowatts DC charger. The third one is the internal use, which is servicing the taxi, bus, garbage, and the logistic trucks. So normally they will have like a really big battery tank, battery pack. So they will have like 60, 120, and 300 kilowatts charger. And also along the river, we will have some port charging. And in the mine area, they will have this really heavy big truck. Normally, they were using the swapping station. So those are our foundation to have our vehicles connect with the grid. But if we want to have the vehicles as a resource to our grid, we need to have some control and informations technology to help our grid to control the energy flow. So the second part, I will talk about the vehicle-to-grid technology and the innovative projects. So if we want to use the battery, the EV as a battery resource to the grid, we need to know what's their potential, the vehicle-to-grid, how much energy we can have. So in community, if we all these 80 million large-scale free vehicles freely charging their EV in their home, we can see we will have a huge impact on our grid. So in the first picture, you can see the gray dashed line is our residential typical load. If we have all the EV connected with the grid and charging freely, you will have this red line here, solid red line here. If we can control them in Y direction, which we call the V1G, you can have this orange dash line. But in the future, if all the charging facilities and the EV cars can support the V2G, which is bidirectional control, we will have this solid blue lines here. So from the grid, we definitely want this solid blue line because it's very flat and stable. It's very easy for us to make the generation plan and also dispatch control. But unfortunately, right now, most of the chargers in China, only a small portion of them are V1G, and only some demonstrated area station have this V2G technology ready. But from the EV owner point of view, you can see from this table, if I bought a EV and when I get tired of this car and I want to replace it, you can see only 20% of this battery's capability are used during this lifetime. And from the cycling point of view, most of the battery technology can easily get to 3,000 cycling times. And in this car's lifetime, you're gonna just use 600 cycles. From the daily aspect, if your car have a 50 kilowatts hour battery, maybe just a 15 kilowatts hour you're gonna need for your daily transportation. So that's a lot of waste from the car's point of view. And definitely when you bought the car, you already paid the batteries. And when you sell the car, it's gonna worth a lot lesser than what you cost when you buy the car. So that's the waste. And if we can control the vehicles by this V2G technology, all the mobile energy storage from the large scale EV will be the most economical distributed shared balance resource in the grid. So this red figure can show you how big the adjustable range from all the 80 million EVs, which we can do a lot. So to achieving the goal by control the vehicles, helping our grid, and also utilize the value from the battery, we build this vehicle-to-grid interaction framework. The framework has 3 layers. The bottom layer is energy layer, which is the foundation of this framework. We will have, from the equipment point of view, we have V0G, which we cannot control. and we have V1G and V2G. From the macro system, we can have the swapping plus storage and the macrogrid. And based on this energy layer, we create this our smart international of vehicles, which is an industrial internet and a consumer internet, which we call this information layer. So based on this platform, we build this load aggregation system to aggregate all the EV or different user side controllable load to provide our grid like ancillary service and demand response and distributed network service. But finally, we need to, after we did all this a lot of work, we want to create this value for both customer and the grid. So we want to lower the charging cost and lower the car's usage cost. And at the same time, we want to improving the grid operation efficiency and promoting the renewable energy consumption. And this table will give you a idea about the value created by the EV grid in integration. So from the business model, we will have the time of use electricity and the service fee, and medium long-term trading and spot trading. For the ancillary service, we will have peak shaving, frequency regulation, and reserve. And right now, the demand response and the distribution network service are also have markets in China. From the load point of view, you can see V0G only participates in very limited power market. But the V2G, V1G, V2G swapping station, the microgrid, almost they can participate in the market, almost everyone. So that's why we want to promote the V1G and V2G and microgrid technologies. So here comes the V1G smart charging network. So in 2030, if we have like 80 million EVs, almost at least 70% are the passenger cars. If all the passengers, all the EV owners charge their cars at home freely, we've based on the data we have right now, their charging peak and their residential load peak, they will have a convergence rate that can reach to 85%. And in Beijing, as an example, the Beijing's load will increase by 20 million kilowatts. And it will need to investigate 60 billion RMB yuan to upgrade the grid to only support the EV load. But from the EV point of side, from the EV side, we can see the residential load at night has about 8 hours within the low load period, and the load rate is only 10 to 20%. So from this figure, if we can shift all the charging load to this low load period, we don't need to upgrade our stationary transformer and upgrade our lines, which can avoid all this expensive investment in our grid. So the V1G technology, our goal is to help our users, 80% of users charge their EV at home, and 80% are charged by the renewable energy during the low load period. And the left figure shows our technology, how we can achieve that. So every V1G charging unit will connect to our control center by the 4G, and some of them are already using 5G to our control center. And the control center will monitor all the connected charging units and also the residential transformers load condition to have a smart charging strategy for every charging units. And our achievements right now, we have already have more than 120,000 V1G units in 18 provinces in China, and helped 150,000 users to charging their EV at home. And monthly, we can shift like 430,000 kilowatts hour from the peak time to the valley time. But so I think we have this large amount of user to service, and we met a lot of difficulties by providing to meet everyone's requirements, because everyone driving habits and their charging habits are different. So in our system, we need to store a large amount of data for everyone to analyze everyone's needs. And based on everyone's need, we also have to consider the grid conditions to make sure the grid are working and the safety requirements. So that's the big challenge for our control center or the platform. And that's why we have a lot of scientific research projects are going on to solve these issues. And this is V2G bidirectional charging. Right now, the V1G has a large impact in our grid because they have a large number of them in our connected to the grid. But the V2G, we only have like 2,000 stations in China, and every station will have only like 10, fewer than 10 charging units. So if we want to push the V2G to a bigger market, we need to solve three questions. We need to consider the EV's owners' consideration about when they discharging their battery, what's their life degradation on their battery. And from the grid owners, if we want to send the power to reverse to the grid, it's kind of a battery station and a distributed solar system. That's gonna cause some issues to the grid. And also the charging operators, because the V2G charger are much expensive than the V1G, and that's gonna be a lot of cost from their side. So it's not just a technology issue, it's also involving some policy and marketing issues. So we need to have a fully sophisticated design to have a V2G business to become to have more and more V2G EVs and V2G chargers. So right now in Beijing, we have two stations. One is in Renji, one is in Zhongzhai. So we tested the V2G can respond to the AGC control commands. The response time will within 1 minute, and we tested the charging and discharging this profile to observe the fluctuation from the renewable power stations. So from the technology point of view, it's really not that hard to achieve V2G. I believe DTU has done a lot of great research and projects in Europe and also in America. But still, from the worldwide, the V2G are limited in small areas, and I think we need to focus on besides the technology issues that we need to solve. We need to propose the policy, good policy, and also the market. And these are the field picture from the GEF project. These are the 15 kilowatts bidirectional charger. And in China, we have 12 vehicle passenger cars, and the battery can reach to 50 kilowatts to 100 kilowatts with a warranty of 3,000 cycles. And after we know about the V1G and V2G, the third part is the load aggregation. And why we need this load aggregation? Because from the power market point of view, all the markets has access criteria, which is fairly larger than the 1 unit and 1 station. So all the distributed flexible moving resource EVs can connect with the grid by the V1G and V2G and the swapping stations. After we using the load aggregation system, we can aggregate them together to fulfill the grid request. Right now, we have the auxiliary service and demand response and renewable energy consumption, 3 markets in China. So this shows how we build this load aggregation system. So pre the market, we will forecasting the market price and forecasting the load, the EV's load. And in the market, we will monitor how the EV's load, what's the difference between the EV's load with the plan. And we can dispatch an adjustment the VBNG and the V2G and some battery storage system. So after the market, we will access all the different resource, their performance, and evaluate the whole market to have a better performance in the next market time. So right now we have already aggregated more than 54,000 units, and the adjustment cumulative adjustment capacity can reach up to more than 1,600 megawatts, and the real-time adjustable load can reach up to 45 megawatts. I think that's the largest one in the world. So 85% of them are the charging stations, and 12% are the electric heating equipment, and the others are the storage and the V2G. And in this auxiliary service market, we have already helped to consume the 77 million kilowatts hour from the wind and the solar generations. And the second market is the demand response market. These two pictures shows how we control and monitor this demand response performance in Zhejiang and Tianjin province. The red line are the EV charging profile without control. But when we know there will be a demand response market, we can actually regulate all the V1G and V2G and swapping stations to lower their charging request to participate in this demand response to help the grid from the load side. So the last part is a blockchain-based energy tracing method for EV charging. To achieve the carbon neutral targets, we actually need to using our EV to absorb more and more renewable energy. there are two main methods. The first one is cross-region renewable energy trade, and the second one is distributed solar energy trade. So other demonstration projects has already been illustrated in around the world. So the local direct connection and the REC certification and load following and the load shifting are all the previous projects about this area. And then we propose a blockchain-based energy tracing system for EV charging. Because the whole renewable generation and consumption involving too many companies, including the trading center, dispatching center, and local government, and the charging operators, and also the end users. So we use this blockchain technology to connect them together to have all the data are transparent into each other. And also with the smart contract technology within the blockchain, we can generating the green pass certification automatically. We will have the trading results, dispatching plan, and also the orders, the user's order information to put them all the information together to generate this green pass certification. And from our app, the user can actually select which kind of if they want to use the wind or the hydrogen or the solar solar power products. And after they complete their charging request, charging orders, they will have this green certificate generated by the blockchain. And this will show where the energy is coming from and using which charging units and goes into their car. And these two, one is for the cross-region renewable energy certification, and the other one is the distributed solar energy consumption certifications. And after that, we want to have this system connected with our carbon trading market. And besides the previous system, we also connect this blockchain with our carbon emission trading center. The first step is based on the generated green certification. We need to evaluate the carbon emissions and then have the trading in the carbon trading center and have the trading results published on the blockchain. And besides this carbon trading record, we can also have this V1G, V2G, and load aggregations behavior recorded on this blockchain. So here comes the final conclusion. So the integrated development of V2G is actually the key to fostering the development of EV industry and enhancing the flexibility and the stability of our power grid, and improving the efficiency of providing service to our EV owners. The scale of EV resource can be aggregated is relatively small right now, but in the future, more and more people buy this EV as they are gradually promoted and applied on large scale. V2G integration will vigorously promote China and even the world energy saving and low carbon transition process. And I hope other listeners can realize from how we achieve the V2G to achieve the vehicle and the grid interactions in the real life. And when we're doing our research and to solve the scientific problems, maybe consider a little bit more about how the real life and how the the power market designed and to have our technology ready. That's all from my presentation. Thanks.